Okay. Hello, hello. Oh. Okay, no, we're good. Okay, cool. I was messing with an OBS setting and I thought I messed something up, but I don't think I did. Okay, so I was trying to... The section has been plaguing me for maybe even a month now, where I just keep trying to read it and keep not doing it. And so I was just starting to read it, and I was like, man, I really need to work out the stuff that they're saying. And I was thinking, well, I may as well just stream that. So let's start getting some screenshots and fill in the blanks on this example. Actually, it's a bad screenshot. Let me take a better one. Ooh, the music's a little hot, isn't it? Turn it down just a smidge. It's now a quiet part, so it's a little hard to judge, but try to remember to look at it. And so we start by taking the Fourier transform in X, just kind of arbitrarily. What I'm doing right now, I'm transferring screenshots onto this journal++ to kind of cobble together the important bits. Hey, syntax. Now let's look at the result for the Fourier transform with derivatives, 4.5.16. This is a place where ebooks could really shine, which is, it's a terrible experience to have to flip back to 4.5 to check what this formula is. And this is a PDF, so it like, it'd be really nice if I could just hover over that reference, and if it could show me like that little snippet, because it's just really lame when you read a textbook and have to do stuff like this. It's easier with a physical book because you can like keep your thumb at your current place and then flip back through with the other hand, but honestly, I'd rather have the hard copy, but that's expensive and it takes up a lot of space. So I've just gotten used to using PDFs. Okay, and so now let's get to this equation. It should be easy, but let's fill in that gap. Doing says I have all the definitions in one place. You take screenshots, can temporarily organize them in a way I find useful for the moment. That's true. It gets even better with modern ebook readers. You just hover over the reference 4.6.2. It'll show the corresponding formula. Yes, that's what I would like. I don't have that like here because this is just like a regular PDF that was scanned from the book or whatever. Probably not. It's probably not a scan, but you know, it's basically that. But like if you properly do it as an ebook, they usually have like links where you can just hover over it and it'll pop that up. And That's kind of amazing. Okay, so the first kind of weirdness with this is that when you start doing transforms on partial differential equations, you have multiple variables being involved. And so when we're talking about Fourier transforms in the last section, we're only doing them on single variable functions. But it makes sense that you can choose one variable to do a Fourier transform on, and for the sake of the transform, you treat the other variable as a constant. And so we're choosing to do a Fourier transform on X. And so capital phi hat, I guess we'll do sub 2 of ky. It is this book here. It's an okay book. I wouldn't say it's amazing, but it's decent. I'm studying out of this book because a class I'm going to take soon is likely going to use it, and so I'm trying to get ahead. No, this is like, I would call this like it very much in the overlap of math and physics. Like both types of textbooks will discuss this thing. Like they'll do it through different lenses, but you could accurately call this physics too. So they're talking about something called the Laplace's equation here. I can bring up my electricity magnetism textbook, and they also talk about Laplace's equation. It's just both, so you're not wrong. Trying to find it. There it is. You had Abeloth as a professor, Catmaster? That's cool. How was he? Like, as a professor? Isn't that Poisson's? Here we go. Laplace's equation is right there. And this is electricity and magnetism. So it comes up. It's a really important thing in both fields. Very old New Yorker. Okay, fair enough. I generally do think physics is hard because you often have to have intuition and have to link everything to nature and physics. Yeah. I think it's cool because of that. It's definitely not easy though. I've heard people say that physics, like, but physics is an approximation to reality, meaning that when we say that, like, the gravity between two planets is g/m over r squared, that's something that seems to hold true, but we don't really know that it's true. We can just see that it does a pretty good job of matching the evidence, and then as it turns out, that's what Newton did, but then Einstein improved on that with general relativity. And so Einstein got a closer approximation, but even then we might still find something that's like not consistent or like needs clarification. Was over Zoom, he had a pot of coffee beside him at all times. Or so often he would pour a fresh cup of coffee. That's cool. He sounds like a character then. Sure, do we help me invent time travel? Sure. So you're saying I guess what math does though, which is viewing it neutral and having to link with anything. Zero values is just something that you have to do something with, which gets you an answer. Yeah, that's fair. That's how a lot of mathematicians feel. It's not how I feel, but that's how many of them do feel. Hey Star, I'm doing well. How about you? Let's read through your question and see if I can do it. Oops. Boat A travels 10 kilometers west of boat B, then travels actually north to get to shore. Okay, so west of boat B. How is this coast? So I guess the shore must be to the north. If boat A is traveling north to get to the shore. I assume they start at the same point here. Shouldn't this just be 16? I feel like maybe I'm missing an image here. I do wish I felt like you do, because I would open the door towards physics engineering. Fair enough. You're going to sleep? All right. Sleep well, Lucas. Thanks for popping in. We're a fan of the complex book by Benck and Fornberg. Send us a couple visuals in that one compared to mostly equations and theorems. Oh, okay. I haven't heard of that one, I don't think. I became addicted to Hollow Knight and category theory these days. Did you play Silk Song? No, I played the first Hollow Knight. I just got the bad ending and then I stopped. Like, you know, whatever the default ending is if you're not paying attention. I'll probably play Silk Song at some point. Probably not anytime soon though. That's awesome though, Mert. You have an important, very boring math lesson tomorrow first. You know everything already. Oh, that sucks. Bornberg Imperial. Oh, okay. Yeah, I still don't think I've heard of it. Oh, to the same point on shore. I see. Okay. Yeah, I understand the question now, Star. Okay, so the path that boat A takes, 10 west, whatever the rest is north. Put an A there. And then boat B, since it goes to the same point on the shore as A, B must have traveled like this. And that's 26. Oh, really, Mert? That's good to hear. I haven't looked up any reviews of it, although I'm sure it'd be very hard for them to mess that up, I feel like. CS Star. Now the main thing that's left to do is figure out what this last side of the triangle is here. Because that's gonna be the distance that boat A travels. We'll do like this side plus 10 is however long boat A traveled. We already know how long boat B traveled. That's just given to us as 26. So for now, I'm just gonna call this I guess small a. And so by the Pythagorean theorem, we know small a squared plus 10 squared is equal to 26 squared. Now solve this for a. 26 squared, I feel like I should know that, but I don't. 676. That feels like a very symmetric number. Oh, is this? Oh, it is a triple Jed. You're right. It's a triple times 2, right? I forget. Is it 3, 5, 12? Or no, 3, 5, 13? I forget. 676. Either way, I'm gonna do it 5, 12, 13. There we go. So this should be 100, or it should be 12 then, or 24. Hey Jay, busts are harder than the first game. It also feeds my souls like inside when I play it. Oh, nice. Yeah, I remember. I don't think there's a dodge in the first Hollow Knight at least, but it still felt a little bit souls like in terms of having to like dodge the stuff and jump around. So yeah, now we subtract 100 from each side. Square root each side. Only take the positive root. I don't know if you're allowed to use a calculator to simplify this, or I'm gonna hope you're allowed to use a calculator for this problem. Oh, it's 24. I should have known that. Because of what Jed said. Lots of materials to dodge are in the game. That's right, yeah. Okay, so now we know everything we need. So the distance A traveled is 10 plus 24, because the first leg plus the second leg is 34. The distance that B travels is 26. So just subtract these two, and that's our answer. So 34 minus 26 is 8. So if that makes sense, Star, let me know. Do people in the West use a calculator for these problems? They don't normally expect students to... they could. It kind of depends on the classroom, Sharda. Usually this is a little bit of a big number to expect them to square root. It is realistic though, because you can factor 576 and do it by hand if you wanted to. No worries, Star. Frick period cramps? 2z plus 7x equals 1729. Oh, it's 2x. Okay. And so you just want to solve that for x? We can do that. So you have 2x plus 7x equals 1729. Oops, that's not a 9. Okay, so the goal here is to get all the x's together, and so we have a 2x and a 7x round to the nearest whole number. Okay, got it. So these are common terms because they both just have an x, so we can add whatever's in front. So 2 plus 7. 2 plus 7 is 9, so we get 9x equals 1729. And now the last step to isolate x is to divide out this 9 from each side. Because what that does is it cancels out this 9 over here, and then we just have division to do on the right-hand side. So thank you for the follow. I'll do this by hand, just to show it. If you're allowed to use a calculator, then feel free to ignore this part. Sharda is already calling it. Hey, Muhammad. How's it going? 9 goes into 17 only one time. Subtract the 9 off. We get 8. 82. 9 goes in... Oh, I remember you. I remember you asking me that every time, too. 9 goes into 82 9 times, because 9 times 9 is 81. Subtract that off, we get 1, then we get 19, 9 goes into that twice. So we get 18. So it's 192 remainder 1. Yeah, I'm just thinking of how, like, we're going to round it down to 192. So it looks like I agree with what Sharda said. And so if you're just allowed to use a calculator for that, you would just get what Jed put there in chat. If you're not allowed to use a calculator, you know, trying to figure out how to round it, I guess the rule will be if your remainder is more than half, you round up, or equal to half, I guess, of 9. If your remainder is less than half of that 9, or whatever you're dividing by, you would round down. So yeah, I'd say that's our answer right there. I don't know if you have any questions about that. Some part of chemistry and physics problems are suitable for calculators, and in exams you need to handle significant figures, and chaotic experiment data can still change. Yeah, that's fair, Mert. Scrimps? You know, you can say that. It's a free country. Your magic words amuse me. Yeah, I didn't go too fast, but yeah, if you have any other questions, feel free to let me know. It doesn't make it true, but I'd say it. I hope you're doing well, Scrimps. If you do have any math questions in the future, there's a whole bunch of people who stream math help besides just me, so whenever I see a new face, I like to let people know that there's more out there than just me. And so I think even right now, Nsiplex Pachinko is live from that list too. Yeah, welcome in. Use a calculator for calculating numbers, that's what they're there for. Not every teacher agrees, Mabort. Hey Jaden, yeah, I remember you. I changed it a few months ago. Hey Snoop. Here my day off watching you do math, all as well. I appreciate you. It's always a little bit crazy to me when I know someone who doesn't like math still watches the stream. I always really appreciate it, even if I like almost like don't get it. This is a really like nerdy thing. Similar in Turkey, in our university exam, we do not allow to use it too. Sometimes special high schools do what I said. Okay, that's interesting to hear. Yeah, I think in America, our university entrance exams don't allow them. I want to say they don't. Usually they keep the numbers pretty small though. Sorry how much we didn't want to look at math while in school, but here we are watching math in our free time. Yeah. It's a lot different when you're doing it out of your own choice, I guess. Oh, you know what, Jed? I was thinking about it, and I wasn't planning to actually do it, but you might enjoy what Saido's posted in the Discord, and we could think about it as a group too. Because it is a geometry problem. Who chooses math? Yeah. Yeah, I will get back to that Fourier transform question at some point, Mabort. That's what I'm intending to do if there's like a downtime. But I do get distracted a lot. So no, I wasn't quite sure of the approach for how you'd even start this one. I can understand visually why this might be true. And so this is from Saidos, who just tends to post a lot of like challenge problems. And so I think what he's saying here is we just have a circle C. Ooh, we should worry about points inside the circle. I only did this with a point outside the circle. But the point is that any line through... Actually, I should use... Do I have a circle tool? Yeah, I do. I think that's actually... This is a good time to use it. Okay, there's... C. What? There we go. There's C. Let's just say P is right here. Then I want a line. Any line through P in this circle. So let's draw a few lines. I should make this a different color. We'll maybe just take 3 of these lines. And so these lines make chords in the circle. Chords intersect a circle in 2 spots. So like, oops. So like from here to here is a chord. And so the midpoint of that thing is what we're interested in. So like, I'm going to guess it's about there. I'm going to guess this one's about here. And I'm going to guess this one's about here. The thing that we want to prove is that these 3 points lie in a circle. And I'm going to bet that P is the center. I can kind of imagine it. If I was better at drawing circles, at least. I like shapes and stuff. Nice. I learned about intersecting points of fire from the military. Also using line to figure out radius. Oh, that's cool. I didn't know that you were in the military. I can imagine that there'd be like, it's probably not super heavy, but geometry is going to be useful in some way there. Consider the line that goes through P in the center of C. Okay. And sorry that I the line in your chats, Sharda. T equals S1? I don't think so. This is that case. Basically drop a perpendicular from the center chord, which will bisect it. From the center to the chord. Then apply Pythagoras to get locus. Interesting. Okay. I'm a box of rocks. Yeah. A lot of stuff you can make it like intuitive though, especially when it's a real life like situation and not just like abstract math. A squared plus B squared equals C squared. Hell yeah, that's it. The definition of a chord. Okay, so I need a new color. Let's get red. Let's guess the center of the circle is here. So drop a perpendicular from the center to the chord. So let's just choose that chord right there. Is that a theorem that bisects it? No, it can't. Because what if I had a chord? Maybe it can. If I had a chord like that, that wouldn't be a bisector there, right? Maybe it is. I'm just like drawing it bad. It does? Oh, okay, sure. Connect the center to each end of the chord. They're both radii. So the angle bisector. Oh, fair. Yeah, Jed. That makes sense. Because it's an isosceles triangle. Y'all are way too intelligent for me. Scrims, my strategy with this question is to wait for chat to carry me. So that's my strategy with a good amount of the questions here. Perpendicular bisector theorem. Oh, I guess that's appropriately named. Okay, so that's a thought there. Sharda wants to apply Pythagoras to get locus. I used my hands to count and got it wrong once. Are we Pythagorasing all the way to P? If we're gonna guess that P is the center of the circle? No. So we're gonna Pythagoras, I assume, just to the edge of the circle then. We want locus of midpoint of chord. Not P. Okay. The midpoint of the chord be XY. Then apply distance formula. From P? Wait, I'm sorry, I keep going back to P. Maybe I should forget about it. But all lines go from circle center to the midpoint. Oh, maybe not. Each chord become tangent to the resulting circle. Yeah, maybe not, Jed. Not from C, center of circle. Well, I mean, center of circle and radius. Right. If you two don't mind keeping it to English, because I can't read whatever language that is. My second chord midpoint. Oh, is it? Yeah, it probably is. Maybe like thereabouts. No worries, Sharda. The center of the circle and the radius are constant. That's so like, am I gonna say that the center is the origin? That's why I'm getting tripped up with the distance formula. Stand up, please. Just speak English. Okay, yeah. So, well, then the distance is just gonna be just root x squared plus y squared, right? So I'm not sure where that's like, I'm not sure what to do with that. We could probably assume that, Jed, and just like skip and like not lose generality. I haven't done any like scaling though. Hmm. Is the point here that, well, I was kind of thinking overall the goal should be to show that all of these distances are equal. They aren't. So so P is not the center of the new circle? Parametric chords of a circle? Like x equals r cosine theta? Okay, yeah. Stand up concept of tetration and the link between this and the exponential. Tetration is basically raising something to its own power, but that's kind of most all of what I know about it. I'm not sure what else to say about it. First apply Pythagoras, then eliminate sine cosine. It's a routine problem. Oh, taking these and plugging it into the distance? Okay. Well, isn't this is going to be r, though? In, like, this r isn't the radius of the circle, it's some other distance. Yeah, sure. I just feel like it should be, but I'm open to it not being the center. Yeah, Territar. That's true. Um, I think the question is saying that like any line you want to draw here should those midpoints should all be on the same circle. And so I drew 3 particular lines, but it should be for every single line. Same circle. So I mean, you can have 4 points. Yeah, I guess I don't know what I'm trying to say. Root x squared plus y squared plus the distance of parametric chords from x and y squared equals radius squared. Equals. So the parametric coordinates that you're using, I know it's Pythagoras. I'm trying to figure out what values you're plugging in here. So you're saying it's the radius. You're doing Pythagoras on like this triangle here. It seems. So, okay, and so the parametric chords are distance from the midpoint instead. Yeah, this is not going to be pretty. T plus this one? You said T equals this one before. T equals this one. I mean, I'll see what comes up. I feel like Google isn't going to know what to do with... Oh, maybe it does. Oh, it does know what to do with that. Oh my god. It's a hell of a figure. Oh my god. Is there a simpler explanation? Oh my god, this is... Okay, this is a better explanation here so far. So S1 is a point on the circle in this case. Wait, yeah. When is the value of S? What is this substitution? It involves differentiation to get the tangent. Uh, no, I'm just confused by this. I don't really want to write it. I just want to see if this Google search brings up something relevant. Stand up, speak English. Oh wait, that this one actually looks. If this one doesn't help, I'm just gonna move on. But the person who asked the question, I doubt knows that t equals s1 thing. Everyone left the chat because of this question. Then they can get out. I don't care. Leaves the chat just so he rejoins the conversation with little context. Hey Zach. The question we're looking at was from Cytos. He posted it in the Discord. I'm very close to just moving on, but Sharda clearly has an idea of how to solve it, and I was trying to understand what that was based on. I'm not really finding a good resource that explains it though. So I need to change my light. There we go. It just comes from a viewer. He's not here right now. He's I believe an American high school student though. But I guess based on looks, PC looks like the radius. I was thinking that too. Oh wait, oh PC is the radius. Oh, I guess yeah, the line through C would have to be. So Sharda was saying that P is not necessarily the center of the new circle, or that it probably isn't. I feel like it should be, but I don't really know that. That's just a gut feeling that I had too. And so there's like a promising start with drawing perpendiculars from the center of the given circle to each of the chords, and that coincides with the midpoint. But trying to do something with that is what's been giving us issues. Erase me issues, I should say. Oh shoot, that erases that too. I didn't know that. Okay, but yeah, I'm gonna keep on reading this the stack exchange thread. If this one doesn't help, I will just move on. But it'd be nice to figure out what this is saying. Hey, Phobos. Oh, YouTube censors links, Sharda. I don't think there's much that I can do about it. I'll try that. I'm getting not the same results as you. Oh, this one? I don't know what that thumbnail is. I was searching it on Google. No? Okay. I'm gonna move on from this question because I'm just not sure. It'll we'll just leave it as an open question though. It's posted in the Discord in math discussion for anyone who wants to engage with it. The meantime, I'm gonna go back to my PDs. So I want to work through this example from the textbook because they left a lot of gaps in their explanation and I want to fill in those gaps. So the original prompt for the question is this first thing here. And the first gap I wanted to fill in was oh yeah, I wanted to get to this transformed. We're going to take the Fourier transform of phi with respect to x and then plug it into this original equation here. And so I wanted to do that. And that means we need to find the Fourier transform for the second derivative of phi. And so I'm using that formula there. Wait. Yeah, this is a little bit weird. Okay, yeah, and so I think they address what's going through my head right here. Well, they they sort of address it. We have to be able to interchange y derivatives in integration over k. Integration over k? Do they mean over x? Interchanging of y derivatives. Is that a typo? It's actually what I guess what I think they're actually. Oh, Territar made a Desmos. For the previous geometry problem. Yeah, K is the variable they've been using for the new Fourier transform. I forgot Territar can do it because Territar is a mod. What's happening here? P and V are the endpoints of the line. End result is the midpoint inside the circle. Well, yeah, so how does this show that these midpoints lie on some other circle? Like, there's some circle that should intersect through this arc that the midpoints are forming as I scroll this point around. Well, that's the question, though, Territar. It is cool that you were able to get it to like find the midpoint like that, but I'm not sure if this answers. I don't think we've proven that these midpoints lie in a circle, though. Or you've proven, I should say. Unless I'm misunderstanding you. Now find the circle containing all the points. Okay, and that's the question. Okay, you know what? Maybe I should back up and ask the stupid question, which is, when they say take the Fourier transform of that equation, they're literally doing the Fourier transform of each side. As in... they start with this, and then they literally multiply through by the exponential and integrate each side. I need more room. And so I guess if you integrate 0, you just get 0. So I'll keep that right side of 0. And so I feel like this has to be a typo because well, let's just write out this next step. All right, see you, Sharda. Thank you for the help. Okay, and so this one is the Fourier transform of a second derivative, which is minus k squared times whatever the transform of the non-derivative function is. This one, we have to take the second derivative with respect to y all the way out front. And this is integration in x. So I'm going to say that's a typo that they made. Or else I'm really not understanding something. And the rest is just the Fourier transform of phi. Yeah. Hey, Fembucks. Mavort, the typo I think that they made is right here. They said assuming validity of interchanging y derivatives and integration over k, but as far as I can tell, we've only ever integrated over x at this point. Like integrating over k is the inverse transform. How's it going, Fembucks? I mean, I guess I could, well, 4, 5, 16. No? I don't know. I'm doing pretty good too. I moved on from it because I got a little, I guess, like stuck. But we were just working on a Cytos geometry problem that you may or may not be interested in. I got kind of stuck with it. There's some in the YouTube chat who seemed to know how to solve it, but I was having a hard time figuring out their explanation. But I went back to my original plan after getting stuck here. Which was to work on complex analysis studying, because this is the section on PDEs, and I'm trying to like go through the examples and fill in the gaps that they're glazing over. And so I think I found it. I suspect that I found a typo in the book where I think they mean integration over x, but it's possible I'm missing something. They mean integration over k. But I guess the magic of this is that we've taken this PDE and transformed it into an ODE. Right here. Oh, and I was originally questioning why there aren't any sines and cosines in this answer. But we are guaranteed to have the sign like it's k squared, and that guarantees a positive number there, so we don't have to worry about cases. And so they then go on to say that we're going to require the Fourier transform be bounded for all positive y. I don't know why. I guess because they want the bounded solution. Does that mean the Fourier transform has to also be bounded of the solution? I don't know. And what is the unbounded solution? I guess steady state heat flow. Why that shouldn't be unbounded. If you just have a metal rod with temperature in one part and not in the other part, you would expect the heat to flow from the hot part to the cold part and then stay there, not go crazy. I guess what they're doing here is selectively throwing out A or B depending on the sign of K. I guess that's what the boundary conditions would do for us. And so this is how they say, like, that's how they get around depending on the sign of K. They use absolute values. The Laplace equation, yeah. With Fourier transforms, which I guess we did take the heat equation and get a Fourier series out of that during your class. I assume in some way that's basically the same thing as what we've done in here with just going straight to doing a Fourier transform. I guess, like, I don't know, there was no, like, separation of variables here, but I don't know. To know the Fourier transform, the wave equation involves separation of variables. I guess it does, but like we just like kind of took a Fourier transform and didn't. If there was a separation of variables here, they didn't say it explicitly. We just kind of took the Fourier transform of it and found an ODE. Oh wait, you're saying the wave equation, but this is, well, they do go over the wave equation later in this chapter, or in this section. I haven't gotten that far yet. I don't know. Doing the Fourier transform b of x comma 0, which I guess is one of our boundary conditions. By h hat k fixes c of k equal h hat of k. Thinking. Is it really so simple that if we take y equal to 0 in this equation, like capital phi hat of k comma 0 is equal to h hat k is what they've basically done here. I guess it should be like that for keeping y a constant, or like keeping y at 0. Okay, so then we get the Fourier transform of the solution. And now we just need to do the inverse. So this is a gap that I want to fill in here. Oh, ooh, they're going to do convolution though. Yeah, okay, first let's do this step here. Finding the inverse transform of that. Get a screenshot of these. Hey, Clonopin Commander? I hope I'm saying that right. I'm still learning the answer to that question myself. A Fourier transform is just something you can do to a function that happens to have helpful properties, mainly that the Fourier transform of the derivative of a function is very simple, or at least relatively simple. It's just it's actually, I happen to have it grabbed right here. This is the equation right here for the nth derivative of a function. You just kind of multiply a constant by the Fourier transform of the original function. And that's really helpful for differential equations. When you have functions and their derivatives in the same place, you can convert everything into just an algebraic equation, basically. I'm explaining this terribly. We're using it here to basically simplify differential equations and solve them. Yeah, I hope that this helps a little bit, but I'm also not sure what your background is. So I can try to explain it a different way if you still have a question about it, but it's basically helpful for solving differential equations. And they're related to a Fourier series. Which can kind of break up periodic functions into like component sine waves. In cosine. You took differential equations like 5 years ago? Yeah, honestly, I'm actually the same way. Oh, I'm getting a phone call. I actually have to take this. I'm sorry. I'll be back in like just a few minutes. Okay, here. Sorry about that bad timing. I do need to send one little text quickly. Okay. But yeah, clone open commander if you're still here. This is very related to the Laplace transform, which you may have seen in a differential equations class. Actually, could I have done the Laplace transform on this equation too? There must be a difference, probably with the domain. I assume the Laplace transform would help here too, though. Anyway, so the circle question is cool. We have 2 votes for it being cool. Did either of you have an idea for how to solve it? Because I got pretty stuck with it. It is posted in the Discord. It's from Cytos. In a math discussion, but wonder if you could reframe the question as considering all circles intersecting the given circle twice. Show that all the points in the plane outside the circle could be the center. Ooh. Yeah, I mean, you'd have to also prove the part about the circle going through the midpoint of certain chords. But that's an interesting thought. Seems like issues right now with voice over Discord. I haven't tried it today. So sometimes it does have connection issues though. Ooh, those chords. I didn't make an update to the graph. That'll be as a brute force rather than geometric. Let me, do I still have it open? Yeah, I do. Let me refresh it. Ooh. You have advanced. This is the Desmos that Teratar made. So the one centered at origin is like the one that is like the circle C that we're given. And I assume this is the circle that goes through the midpoints of all those chords. I was wondering also about the case where the point is inside the circle. I assume there's still something you can do there. I didn't try to draw it though. Why don't I do it with Teratar's Desmos? Oh yeah, I guess it makes sense. We also have voice over Twitch. Oh, that's true. There's a stream together thing. If you have 3 chords and draw 3 lines, you'll find the center of the circle. So yeah, I mean that, like, I was kind of confused about that because that's just the point P that was given in the problem, right? They left now, but Shard in the YouTube chat was kind of seemed to think that P would not necessarily be the center of the new circle. I'm still not sure why. in case it helps to let anyone else play with that Desmos. There's the link there. The fact that one chord always passes through 0, 0 means the circle must be in between P and 0, 0. Territar says. The green circle is because it has 0, 0 on it. There should be a reason for that. Man, the fembox stat just keeps going up. The midpoint of the chord passing through 0, 0 is also 0, 0. Yeah, okay, that makes sense, Territar. You know, this isn't the shape of circle that I thought. The more that I look at this... Wait. Am I... There... Oh, wait, this is the point I should be dragging. Okay, yeah, this is the circle that I thought it'd be then. Le Taser Wish de Mika? Doing calculated C++ by myself because I hate the Windows calculator. Nice. I'm doing well. Thanks for asking. That's hilarious. I love that attitude. I assume you're gonna do more than just a regular like function calculator, right? What are you gonna put on it? Yeah, so the circle thing's definitely an interesting problem. I'm still not sure like where to take it, but feel free to let me know if anyone has another idea, or if I'm not live and you have an idea, post it in the Discord. Ooh, derivatives. Oh, so you're gonna do like a symbolic calculator. I assume, at least. Hey, Phantom. Okay, so I was going to verify this statement. Oh man, my stupid bot still isn't working. Why is my bot not working on YouTube? I just remember that. Okay, anyway. Phantom, you can post them right there in chat, or you can put them in Discord. You failed a math Olympiad? Okay, I can't help with the Olympiad questions, though. I'm sorry. I can't really do JEE questions if you're studying for that. Found a good general purpose math calculator that isn't Desmos. Oh, yeah, it is JEE. Yeah, I'm sorry. That's just a little bit, I've tried this question before, and they're just a little bit too hard for me. Dang it, it's that time of day where the sun is going to be in my eyes. Fizzbuzz, hello! Yes, I'm hanging out with my friends Fourier and Green, and Green's pet function. Found a good jumper's math calculator that isn't Desmos. I just use Wolfram Alpha, but even then, it's not necessarily good either. One chose for a while, I probably think it's okay to look at the solution. I think so too. Without I wasn't bothering to try to Google it because Cytos often just invents problems, which is cool, but makes it hard to find a solution online. That one might have one out there. But yeah, in the downtime FizzBuzz, I've been working through this example problem from the book on Laplace's equation using Fourier transforms. And their solution leaves a lot of gaps for the reader to fill in, so I'm trying to fill in those gaps right now. I think I've already caught a typo with one thing that they said here. Phantom, yeah, I'm sorry, I don't know what the black book is. Yeah, I basically, I've only been introduced to PDEs pretty much, and during my degree, that was like, oh god, like 7 years ago now. Yeah, Phantom, I'm sorry, I can't help with JE. And we did do Laplace's equation. I don't think maybe we actually might have done with Fourier transforms. It's been way too long though, I don't remember it. It's kind of crazy when I go back through. I still have all my old notes and tests and stuff, and when I go back through and look at it, I'm like, wow, I did that? I was actually like doing things. But yeah, so I want to verify the inverse transform of this. It's really not all that important to the question, but I want to do it. Actually, this is going to be a really easy one, I think. Maybe I shouldn't speak too soon. If you do applied math stuff in your master's, you'll see PDs again. Oh yeah. There is in the third quarter, there's going to be PDs class for sure, and there's probably going to be PDs mixed into some of my other classes too. Shift function analysis is a bit less scary, serious of a course. The theory of existence and uniqueness of linear PDs seemed really neat. Oh, really? I wanted to learn the existence and uniqueness for ODEs, but the textbook I was using just said this proof is too hard. We're just going to give an outline of it. Go find an analysis book if you want the actual proof. Phantom, I'm just doing some studying on partial differential equations right now. Vedic, for improving in math, unfortunately there isn't much of a better way than just practicing. There's no substitution for just kind of grinding through problems. I imagine for PDs it's even worse. I do also wish that functional analysis was less scary too. Do you need Banach fixed point theorem for the existence and uniqueness theorem? Maybe. I don't remember. Mass point geometry? I haven't heard of that. Or the... Yeah, I'm sorry, Phantom. You asked me about things that I just have never learned about. Like, in the way of attempting a question, what should be the mindset according to me? One where you forgive yourself for making mistakes. And just view it as a part of learning. Sorry, I'm figuring out something I can like. I could put some tape over the gap in my blinds. That's what I really should do. just wondering if there's something that I can do that's even lazier. Just end up developing theory of generalized derivatives, delta functions like, oh, okay. I have a book, Perco, that gives a proof that is 3 pages for the uniqueness of ODE solutions. That's probably actually a short proof for that, I would guess. This didn't help. AOPS? I'm sorry, Phantom, you're asking about, like, the few questions that I don't like taking. It guarantees the existence and uniqueness of fixed points of certain self-maps. First, a constructive method to find those fixed points. I mean, maybe this comes up for the differential equation stuff. I don't know. Oh yeah, hey, there you go. Yeah, sorry, Phantom. I'm just gonna keep on going with the studying that I'm doing right now. So in order to deal with absolute value, well, actually, okay, we're integrating with respect to k here. Wait, no, this absolute value isn't easy to deal with, is it? Do we just do cases? I guess we do cases. Let's let k be positive. So this is going to end up being 1 over minus y plus ix e to the k minus y plus ix. Wait. Why is this so weird? Isn't this bad? I can't just say k is positive. I break it up into 2 different integrals, I guess. I just realized that we're integrating in k, and k is going from that range. So this is how we get positive k. And this is how we get negative k. Ooh. Well, we chop the negative off, right? Yeah. Okay, and so I think this is better now, because before I was getting a diverging integral, and this should converge because the e to the I infinity if ever we're just gonna say that's 1. Or like it's not I feel like the thing that's important is the radius is going to 0, and we don't care about the rotation. There's probably a better way to explain that, but the limit to infinity I'm going to say is 0. When k equals 0, we just get e to the 0. So we're going to get minus like that. Now over here, 0 is fine. Minus infinity goes to 0. Hey, Mom. Now I guess we're going to get a common denominator. So I'm taking that, multiplying by y plus ix. So we get minus y squared minus x squared. Um, okay, and so now we're, okay, yeah, we're going to get a positive y squared. Does that match? I think that matches. Oh, I'm off by a factor of 2. Bruh. Because it's 2y squared. That's not the thing to erase. There we go. Okay. Wait, it's only y on top. Bruh. Yeah. Thank you, Femlux. Okay, and so that really wasn't the important thing to show here, but the unfactorial brick compilation. 24 hours long. Brick is so good. It just it suits every situation. I probably have set enough times to make a 24-hour compilation. Okay, so I do want to apply the convolution formula. Because what we're doing the inverse Laplace transform of this bad boy. And so that's the product of two Laplace transforms. So the inverse of that will be the convolution product. 4.5.17. So where are we at? We are at capital phi hat of k y is equal to capital H hat k, the Fourier transform of the boundary condition, times e to the minus absolute value ky. So that means regular old phi of xy, doing the inverse on k, that's not the formula that I wanted. Is it? Wait, I think I grabbed the wrong thing. That's the setup to the formula that I wanted. But this book is a weird thing where I feel like what we're doing is 4.5.18, but this isn't the first time they refer to 4.5.17. But we have the two transforms and we want to invert them. So I feel like this is the one that we actually want. Yeah, I got weirded out because where are you? It says 4.5.17. And not for the first time that it's done this. But that's not like we're not using that, like that's the setup to the equation that we're actually using. So it's going to be we're going to do the e part will be the f of x minus x prime. And the thing we're doing it on is that x there. So the 1 over pi can come out from y over x minus x prime squared plus y squared times the just h of x prime dx prime. That does match. Okay, good. Convolutions are super weird for me. I feel like I understood them. I thought I understood them when I learned them years ago in differential equations. But I feel like since reading this book's explanation, I don't understand them. And so then they do a Dirac delta function. As an example for a boundary condition, which is, what would that mean? Would that mean that we have, if this is a metal rod with heat, it means that we are initially heating, and h of x is the boundary condition for the x-axis. it's constant in time. So it means that we have a constant sort of heat from the x-axis. Is that the physical meaning of that? Because I think of direct delta as like happening in an instant in time. But I think this is happening in an instant of space. Well, I guess x equals zeta. Oh, wait. Not the entire x, that's just 1 point? I guess that makes more sense, right? We have a metal rod and we're heating 1 point on the x-axis. Yeah, okay, okay. Small, very, very hot portion of the metal rod with some fixed amount of heat energy. Okay. Like we're taking a 1,000-degree knife and just touching it to the rod. Constant temperature is a perfectly reasonable assumption. Okay, and so direct delta functions are kind of neat with Fourier and Laplace, I think. Or at least Fourier, probably Laplace too, though. I guess I need to go back and remember why these are special. Because the convolution just gives you the original function back. Okay. Yes. So that's why we just take this integrand and plug in zeta for x prime. Okay. And so use the word fundamental solution without saying what's fundamental about it. Maybe they just mean important? But I feel like in differential equations, fundamental solution has a specific meaning that they don't talk about, I don't think. Sorry, I'm just replying to a text. Okay. Oh my god, I'm on. Did I say hi? I saw that pop up. I might have forgotten to say hi. If I didn't say hi, then I'm sorry. Isn't the fundamental solution the solution to the inhomogeneous part? Oh, they might talk about that. Oh, they do. It's the next sentence. I don't know what inhomogeneous means for PDEs, actually. Is it the same thing? Like, would we replace 0 with some random function of x and or y? But this was a homogeneous equation that... Delta function inhomogeneity. Yeah, I don't actually know what that means here. It's a whole linear subspace of homogeneous solutions. Okay. That makes sense. I'm still confused how we got this when we started with the homogeneous equation then. Because this is just a boundary condition. Taylor is saying it's also the same? Okay. We don't want to stray b of xy equals something plus ax squared minus y squared floating around. Oh, wait. Oh. What? But a homogeneous equation equals 0. Isn't that taking the homogeneous part? Or that's like taking the inhomogeneous part out. That's confusing phrasing to me, but... So then, does this sentence mean... if the 0 was instead the direct delta function, it would also solve that? Yeah, okay, like, it's questions like that that kept me from getting that far in this section. From the boundary... I'm just gonna... I at least half understand what's happening here now, which is an improvement. From the boundary values... Okay, yeah, this is the special boundary value for direct delta, centered at zeta. We may construct arbitrary initial values. Yeah, okay, this is where really... I think this is where I probably stopped reading the last time I was trying to read this. If del squared g equals 0, then for any solution of del squared f equals h, f plus g also solves... I've had that feeling too, Fizzbus. No worries if you are. I appreciate you even trying. For any solution of del squared f equals h, f plus g also solves del squared f plus g equals h. So we focus on the inhomogeneous part to remove the redundancy. Okay. Yeah, this still feels weird, but that's making a little more sense. It just still feels weird that, like, I feel like the boundary condition here should be separate from the whether it's homogeneous or not, but it feels like they're somehow linked still. Oh yeah, Clone Open Commander, thank you for the follow. The namespace of all G that solves del squared G equals 0 is the homogeneous part, right? Oh my god. Okay. Oh, okay. I see what they're saying now. I think. Well, I think I see what this equation is doing. They're just taking the boundary condition we already had, and you can always express it if you just feel like it as a convolution product with the delta function. If you really want to go wild, like you can do this with any function you wanted to. Because the Laplace equation is linear, that by superposition, which is probably what Fizzbuzz, or it's similar to what Fizzbuzz was saying. Uh oh, I'm sorry, Clone Open Commander. I really I know that some people don't like uh that word isn't a big deal for a lot of people, but at least in my chat, I really prefer not to have it here. Um, no judgment, but I just feel like for like educational stuff, it's better not to use that word. No worries though. So I think the reason you can't do that is the Dirac delta function isn't a real function. It's really kind of it's not like if you want to actually do an integral with it, you should think about kind of like the finite version of it where it's just very narrow, but not exactly like 0 in that width. And then you take the limit at the end. I think that's the proper way of doing it. If you did take the Dirac delta function out before integrating, you would get the wrong answer, I think. Because like this integral as it's stated doesn't actually make sense. And so you should go to like, I guess what this book is calling just the regular delta function, which is like the Dirac delta, but it has an actual width. That like non-zero part. Hey Pui, Arnold uses this intuition in his book that any function is an infinite sum combination of delta functions. Oh, that's kind of funny. It's an infinite sum with all real numbers, right? Like not just like integers. That's funny. I guess I can kind of see how see the idea with how this kind of grabs you one value of a function, and so in theory you could get any value of the function you want with this like version of it. But yeah, Shane, thank you, thank you. Yeah, I'm finally settled in. It was a real adventure at first, where I basically rolled into town with my mom's car full of basically everything I own in the world. And my plan was just to sign a lease as quickly as possible. I managed to do that. Like I showed up on Wednesday and I managed to do that on Friday night a few weeks ago. But then when I actually like moved in, like everything was broken. Um think my landlord is a really good dude and he's been really on top of fixing stuff, but since I moved in, I've gotten a new fridge, a new oven, a new water heater. They fixed the leaky bathroom sink. They've cleaned mold for multiple places. Yeah, I guess those are like the major things that have happened. It had been the unit had been vacant for a while apparently, and uh, it just evidently wasn't really maintained. But so at first I was really stressed out. Like, oh my god, did I sign a lease on a shitty place that I'm going to be trapped with for a year? But no, it's now actually like livable. So I'm able to relax a lot more and actually think about math again. But yeah, I hope you're doing well. I still have another 2 weeks before I start taking classes, but I assume that the classes you're teaching have already started. Um, because the Laplace equation is linear, this is we find superposition of the general 3 weeks in. Oh dang. Hopefully it's going smoothly so far. Oh, wait. Is this okay? I think this equation is some messed up mishmash of this equation in this equation. Or this equation in this equation. Like they basically, this part of the equation looks just like Green's function. I don't know why this is superposition though. I don't know. It's going okay. Students are starting to warm up a little bit. Concerned about more than I would normally see though. Lots of zeros. That would be concerning. I remember hearing you talk about how you structure your classes with, like, intentionally making it easy to like succeed as long as they always put in a little bit of effort. Hopefully it, I guess it picks up. What do I do my degree in? So I'm about to start on a master's in applied math. The quarter starts in another 2 weeks. I think on the dot. Well, the orientation is on 2 weeks. The actual first class are going to be 2 weeks and 2 days. Noting that zeta or x prime are dummy integration variables. Okay, so I don't know why this is superposition. This just seems like substitution. But like with most of this chapter or section, there's probably something I'm missing. And now that question was so much fun. Let's solve it a second time with a different method. Question, wait, 4.6.5. Something's called Poisson formula for a half plane. Okay. Wait, so what's the shape of this rod again? And a semi... okay, this is a semi-infinite rod of heat. Or rod of metal that conducts heat, rather. I definitely have one of those laying around in my closet. All right, cool. Can open. You don't have to say if you don't want, but like, what's your background in math? It's always cool to hear about that. So I don't know if I did it when you were around. If I already did, I apologize. But in case you're interested in math streams in general, there's a whole bunch of us out there. The list keeps on getting longer. So yeah, just earlier today we had Eats the 2i Pi / Zach streaming, and Simplex Pachinko. I remember seeing him streaming when I started. He might still be going. And then Academy Useless Ideas was also streaming earlier too. Computational chemistry background. Did a lot of quantum mechanics and physical chemistry that involves some math. Oh, that's awesome. I'm trying to think. There aren't any chemistry streamers that I actually know of. I know some people who like chemistry who tend to hang out in some different chats, but not like a streamer. Yeah, I'm sure with like you got in FizzBuzz's interest, who also streams. He's in that list somewhere. That does sound super cool though. The chemistry that I've taken I didn't like, but I think, oh, the place is looping. Let me fix that. I haven't listened to this song in a minute. Where is it? There. But yeah, like that stuff that you're doing probably would get me interested. Did a tiny bit of work with Lou Sham of density functional theory fame. It's not a successful project, sadly. Lou Sham? I have not heard of them. It's a funny last name, though. Density functional theory. I haven't heard of that either, to be honest. Density functional theory. Then that density sounded out. Oh, computational quantum mechanical modeling. Electronic structure or nuclear structure. Many body systems. Okay. Oh, Wikipedia actually explaining? This is rare for a Wikipedia article to include a little bit like that. Normally they just like, they don't explain it. They just expect you to click through on the link. And then that link uses a term you don't know, so you need to click through on the next link. And so on. It's a big thing in QM calculations. A lot of people do DFT. Oh, okay, okay. Wait, so does this get you a function? Is it like a new... Okay, so I'm used to numerical methods where you just estimate a number. Is there a numerical a numerical method to estimate a function with functionals? Does that even make sense? Probably doesn't. You just estimate the parameters for a function, right? You can do gradient descent with the functional derivative? Really, Teratar? That's kind of cool. I've only barely dipped my toes into like functionals and stuff like that with when I was trying to do the general relativity stuff. And it's so crazy that you can do calculus on functions and not just numbers. So numerical solutions to PDEs estimate functions. I wouldn't know. I never done a numerical solution to a PDE. I'm gonna have to do one at some point during my degree. I'm probably gonna have to do many. I don't know. So I'm thinking with like a regular ODE, you would get like slope fields and stuff. That's a good question. I don't know. No, the test function is the direction you are differentiating. Oh wait, I should read the other chat first. I think the variational derivative is very similar to a directional derivative, and that the test function is the direction you're differentiating. Ooh, okay. That's still weird. Because I wouldn't think of functions as something that are like ordered, I guess. So how do you have a direction without order? I'm sure, you know, it works because people have done that math, but it's just really hard to wrap my head around. Right. That makes sense, Territar. Gradients and functional space usually used in machine learning, namely gradient boosting trees. Like the XG boost is based on that idea. Oh, okay. Gradient boosting trees. That's it sounds like I feel like that's like some smart sounding gibberish that they will make up for like a sci-fi movie or a TV show or something. The same way that when the variational derivative is 0 for all test functions, the functional is maximized or stationary. Right. I think. I missed. Oh no. No way. I thought I read it. When the directional derivative is 0 in all directions. I think I saw all your messages, Territar. I might not have read it out loud. The directional derivative is 0 in all directions. The gradient 0 is maximized. Okay. No, I maybe I probably just didn't read it out loud, but I did see it, yeah. Hey FA 3.14. You know it. Delicious. You must be off work, right? Hope it was good. Okay, so wait, such a pair of formula. What pair of formula are they referring to? Oh, this is bad. I don't even understand the premise of the question they're doing now. I don't know. Let's just keep reading, see if we figure it out. 2 days off now? Hell yeah. It's your weekend. Man, imagine having Monday being your Friday. That would feel weird. Using a large closed semicircular contour. I assume that's just what I'm just a regular semicircle that goes to infinity. I shouldn't have done that. Figure 4.2.1. I was thinking equation 4.21. Okay, yeah, that's nothing special. It is, yeah, it's like it's upside down. Like Monday's supposed to be the worst day of the week, but now it's the best day of the week for you. Mondays are chill, Sundays are hell. Oh, really? Is it just like super busy on Sundays? I assume the cafe. That's crazy, honest. Well, I guess that makes sense because people have the day off. Second formula. Yeah, right. Adding and subtracting yields two equations. Portion, sure. Z is x plus iy. Zeta is x prime. This, I think this is, I should take this aside and derive this. Because I'm not seeing the algebra that they're doing. Okay, so 1 over 2 pi I. Now when we do the substitution, oh, okay. So the contour changes to just a regular integral on the x-axis because the arc disappears. Makes sense. But z is still any number. Okay. And so then this f of zeta becomes that disgusting thing. I'm going to say x prime comma 0. One over zeta. Ugh, I hate zeta. Actually, I don't even need to write zeta because we're substituting. I need to do a power ranking for Greek letters. Because zeta is going to be the second worst one behind Kasai. Okay, so then this zeta here becomes just an x prime because y prime equals 0. Minus x plus iy. And I assume we'll start with the plus case. 1 over x prime minus x minus iy. Dx prime. Okay. So now let's get a common denominator, and we should get something that matches the first equation. Oh, this is annoying. Bruh. I need a bruh counter. Can I automate that? I bet I could automate that if I went through the trouble of setting up a thing to listen to my mic. So I'm taking this, multiplying it by the same thing but with a plus. No, I'm not. That's the sign that gets flipped. Bruh. Okay. But I'm gonna work through this. So, okay, oh my god, dude. That times that, done. That times that. X prime x minus iy. That times that. X prime. It's not a 1 anymore. X plus iy. Plus x plus iy, x minus iy. Yay, algebra. Okay, that's just the first fraction. But wait, there's more. Oh, well, okay, we don't know. I can save myself some writing. I'm just gonna put a question mark there. Because it's gonna be the same thing as this. So why do double the work when I can do half the work? Well, the same amount of work. Why say many words when few words do trick? Okay, so the numerators what'd the numerator do? 2x prime minus 2x, and the iys cancel? Yep, they sure do. The denominators do we have to do this the old-fashioned way? What's the goal? X minus x prime squared. We have to do this the old-fashioned way. Xx prime. So we will get xiy minus, or x prime iy minus x prime iy. So that goes away. That's nice. We get another xx prime. So I'm going to just slam a 2 right there. We're going to get a plus x squared. We're going to get a plus y squared. Aha! I'm onto your tricks. I see it now. Okay. I know where this equation comes from now. How about the other equation? It's the same thing, but it has a minus sign. So only the numerator should change. The x primes cancel. The x's cancel. So we get iy plus iy is 2iy. Okay, yeah, okay. It is what I thought it was. Now calling f of z equal to that. Oh. Why is the X canceled? What did they do? You want to hear the words that X said, okay? It's okay, it'll just stay quiet for a few years and then it'll come back. Yeah, you should become a comedian, FA. I would go to your show. I'll be the only person in the audience, but I'll be clapping super loud to make up for it. So you telling a joke and be like, clap, clap, damn it. The imaginary part of the first and the real part of... Why are we doing that? What? Oh. Oh. Ah, okay. Oh, ah. That makes sense why we would do that, yeah. Okay, yes. I see it. And so real part, imaginary part. Identifying u of xy as phi of xy. Now, how do they do that? Because f... Oh. Haha. So v is also a solution. Or I guess we're just choosing u for some reason. Choosing you, Pikachu. Similar for these formulas are valid for a half plane. Similar formula can be obtained by this method for a circle. Example 10, 2.6. Oh, wait, example 10. Example 10? It must be problem 10. Oh, this does look similar. Huh. Oh my god, this is such a long problem. I don't want to read all that. Hey, logarithmic. Ugh, I don't know why I had a hard time with that. This is the book here. I'm mostly studying out of this because I'm going to take a class that I think is going to use this book, and I'm trying to get ahead. I would say it's just like okay though. It's not like amazing, but it's not bad. No worries. Okay, well, I actually got through an example from the PDs section. Okay, wait, how many pages is this? Okay, we started on page 285. After 2 hours and 40 minutes, with some detours to work on people's problems, we got partway through page 288. How much do we have to go? Oh my god. Please, please, please end soon. Please go to problems soon. Okay. We only have 12 more pages. Yeah, I mean, I mostly just pointing it out for the jokes. I think this is a good use of time. And honestly, not a bad pace for the stuff that I'm learning here. But yeah, no, it's just PDs are difficult, and I think it's worth it to spend time with them. Okay, so now we get to the real heat equation, which involves a time dependency. Just going down to one dimension and taking k equal to 1, just because they can. Pythagorean equation all along. I wish. There's actually, this little thing here does look a lot like Pythagorean equation with the squares and stuff. Yeah. No, unfortunately, as far as I know, that this is going to be completely unrelated. Is there a ship I can draw? I don't think so. There might be one for all I know, though. Yeah, easy. Just take the square root. No, it's actually, no, yeah, these aren't even actual squares. Like, it's not like exponential, it's not an exponent, it's actually a superscript, which is even worse. Ugh. Second partial, same thing. Yeah. Yeah, squaring two derivatives. What's really the difference? Okay, so we're going to find the Green's function for the heat equation. With this boundary condition, which is the direct delta function. So this is our same metal rod. We're taking our 1,000-degree knife and just putting heat on a very small part of that rod. And we're seeing how that heat distributes throughout the rod. What did the previous example tell us? Did it tell us the end result? I don't know. Because this feels like the real problem here when we have the derivative in time. Well, yeah. I don't I don't know what the solution to the previous problem actually got us, like physically. Just not worry about it for now. Okay, but we're starting with our good old Fourier transform. So once we take the Fourier transform of the heat equation, we get that. We're doing the Fourier transform on X, yeah. Oh, that's confusing. You can't... Okay, I know it's the convention to use K as the constant here, but they've also been using K as a variable for the Fourier transform. So this K is completely different than this K. Okay. Oh, okay. Minus K squared. Phi hat KT. Phi, ooh. Where are you coming from, my friend? Oh. No. Okay, this is an ODE now. Yeah. A first order ODE of that. And they already plugged in the initial condition. And then why is phi hat of K0? They're explaining that here. It's a Fourier transform. Okay, for our boundary condition. Form a PD by eliminating an obituary. I'm not sure what that means, Janesh. I'm sorry. Okay, but yeah, so this is the Fourier transform of the boundary condition, which was the direct delta function. By the inverse Fourier transform. Calling G. Oh God, what's happening? Okay, so yeah, we're just doing the inverse transform of this. We're going to name it equal to G. So then G is the inverse transform of that. And that looks like a contour integral. Oh. Oh. Wait. This is one of the ones where you have to complete the square in the exponent. I remember doing this for some other problem recently. It's a real pain. Okay, I don't want to do this algebra. But I think I could do this algebra if I wanted to, and that's good enough for me. Because I think all they've done here is they took the exponent, they completed the square, the constant term with respect to k got shoved out in front. So you're just left with e to the minus k minus something squared. Why is the t outside? Is that causing an issue? I think that's fine. Yeah, that's fine. Which means we divide by t there. And then you can use this known result. Okay, I think I get where this comes from now. At the end, it gets normal. That's a pun, isn't it? Okay. Do I understand this now? Yes. I think. Arbitrary initial values are included again by observing that. Which implies the general solution is the convolution of Green's function and the initial condition. Oh, wait. Oh, I was calling it a boundary value, but it's an initial condition now. Cosmolano. What is the side length of a cube with volume? I'm gonna guess it's 69. Dr. Gold. Welcome in, everyone. Is it 69 420? Maybe. How was your stream, dude? Thank you very, very much for the raid. Welcome in, everyone. 420 69? Almost. Hope you're doing well, Cosmolano. Shanktrix, hey. Dark Aspect, hey. You guys probably know me because I feel like Gold and I hang out in each other's chat all the time, but in case you don't, I'm Don. I do math help streams, just like him. Since things are slow right now, I've been doing some studying on some crazy looking higher level math called partial differential equations. I'm happy to do even just 2 + 2 = 4 though, if someone has a question. But yeah. Welcome in. Puika was saying about this bit, and it's also exactly the distribution of Brownian motion at time t. Oh, I actually only just learned what Brownian motion even is. That's kind of cool. Looks like field theory. Maybe it's involved somewhere because I don't know field theory, but I've been studying complex analysis, and I'm currently on the section that talks about applications to differential, I guess, partial differential equations. So we're looking at the heat equation in this example. Giodi, how to find absolute min and max in algebra 2 graph? Are you given a, like, what are you given there, Giodi? Are you given, like, just a function? Are you given a graph, or what do you mean? I need a little bit more information there. You're given a graph. Okay. So I'm just gonna invent a graph then, and we can talk about it. So I feel like these types of questions, they'll often kind of throw weird graphs at you. So how should I do this? Um, let's say we have a piece of it that goes like there, and then maybe an open dot. Actually, let me do this in a different color. An open dot there. Then maybe we have a linear function in this piece. Actually, I want to make it slightly different. And then maybe it just like flattens out in this piece here. It doesn't break its together. Okay, then let me change that. I'll draw, I think a parabola is maybe then a good example to start with then. Just like that. I should actually put some scaling on these axes. The open dot means the function turned to go into another dimension, right? Exactly, yeah. Okay, like a quadratic or a parabola. Okay, yeah. So we can do a few examples even, but just to start with a one that's like a little bit simpler to think about at first. If you want to find the absolute minimum or maximum of this graph, let's start with the absolute minimum. So absolute means like taken over the entire graph, the lowest it ever goes. So the lowest it ever goes here is just like on this, like it's that point right there, the vertex of it. So since I put scaling on the graph, we can just look at it and say exactly that the absolute min is -1. This one, the absolute maximum though, it just kind of shoots off to infinity on each side. And so this might vary depending on your class, but at least the way that I was taught, we would just, you might say it has no maximum, or you might say that the maximum is infinity. So, okay, it sounds like you would say infinity. So it's kind of like whenever you have an arrow just kind of shooting up like that, that means that it's going to be infinity. Same thing, if we had a parabola instead that was facing downward, the minimum would be negative infinity, because now it's going downwards to infinity. Can I do a weird one? Yeah, and so I assume still not like broken up. So let me okay, I guess let's try like this one on for size. This is like some cubic function here. So here, the minimum, over here I see there's an arrow pointing downwards. So we're just kind of going off to negative infinity for our minimum. Hey, the God mode. And then likewise, we have an arrow pointing upwards. So our maximum is also going to be, or it's going to be positive infinity. Hey, Skirtle. And so this will, it's weird because we don't really have an actual like number to plug in here. Now there's something special about like this point here and this point here. We would call it like a local minimum or a local maximum, which you might not have learned yet, but we're talking about absolute. So for now, we don't care about those. Yeah, or relative is another word. Yeah, for like absolute min and max, that's the only other situation I can think of is if it's not defined for all x. So like if you have a function that just kind of like stops with dots like that. This is another thing maybe that they could throw at you. I guess maybe I should have drawn it slightly different, but for me, it's still just like looking at it visually with that's the absolute min there, whatever that point happens to be. That's the absolute max here. But I guess I could have drawn it a little bit differently to get a more interesting example. Like that. Now the maximum is there and the minimum's here. So I don't know. I hope that helps. Let me know if there's a different situation that you're thinking about though. In the God mode, I see your question. That does not look like the type of question that I know how to do. I'm not very good with functional equations. So I'm sorry, but I don't think I'll be able to help out with that one. Yeah, no worries, Geody. Welcome in. If you have questions in the future and I'm not around, there's other people on YouTube who do math. Oh, is this the command? Hey, okay. So at least on YouTube, there's I kind of use ideas in actual education. On Twitch, because I stream to both YouTube and Twitch.tv. On Twitch, there's a lot more streamers, but on YouTube, there's at least those two there. Guys, is there anything else? Let me know. Otherwise, I'm going to go back to the studying that I was doing. If the roots of those, or if the roots of that are alpha and beta, I could do that like the brute force way, the God mode. I don't know if there's like a trick to doing that faster, but I can do it. The way that I know how, at least. I'm interpreting these as exponents. The parent function, it's just unfortunately it is a little bit of just memorization. Let me work through this problem and I can talk about that at least a little bit though, because it the transformations, they do have an intuition to them, but I still even now have trouble with it sometimes. Click open, got the factorization. Yeah, that looks right. X minus 3, x minus 2. So the roots of this parabola. Oh wait, I'm just making sure. Okay, yeah, that I copied it down right. Are 2 and 3. OB. Hello, hello. Thank you so much for the raid. I hope your stream was good. Welcome in everyone. We're just working on this problem from the God mode in YouTube chat. I have a feeling that I'm getting tricked and there's some easier way of finding that value, but I'm just going to do it the old-fashioned way. You done messed up, Aaron. Yeah, for anyone who's here, check out Obi, aka Insubux Pachinko. He also does math help. I think I saw you just streaming about you've been doing those streams on like building thinking classrooms and about kind of generally how to do education better, which is cool to see. Yeah, we have our alpha and beta now, so let's just plug it into here and we can find our value. So 2 cubed plus 3 cubed times 2 cubed plus 3 cubed. That's a bit of math, but we can do it. 8 plus 27 times 8. Ugh, plus 27. 27 times 8. First off, let's do 8 plus 27 is 35. 27 times 8. 56, carry the 5. 296? Question mark? Nope. 216. $35? I don't... Oh! I realized that it's because there's an in the way it was copy pasted. I see. It's supposed to be just that. It's because of the way that I was just solving a slightly different question. There we go. So the God mode, let me know if you have any questions about that. 6 cubed. Oh, I was wondering if there's a trick like that, Pooey. How to find negative intervals and positive interval graph. I don't stream every day. I don't have a schedule right now for my stream. I just kind of turn it on when I feel like it. Sounds good, Lugabo. Thank you for the question. Hey, Jad. Did linear algebra and got an A+. You helped me a lot with the questions and question examples. Oh, nice. Well, thank you so much for coming by and letting me know that you did well. That's awesome. Happy to have helped, and good job on doing the work for yourself, too. 7 cubed? No, I don't know. Its teaching style emphasizes empirical research-driven teaching practices that foster greater levels of student thinking, both intensity and length of time. That's awesome. 349? 343, okay. Test on graphing on Friday? Okay, so let me catch up with GOD's questions here. 343, there's probably... That's like a symmetric... Like, that's also 11... Does 11 go... That's 11 times something, right? That looks like in a multiple of 11. 343 divided by 11. It's not. Never mind. Okay, so Geodu was asking about parent functions, negative intervals, and positive intervals. I'm not sure what that part means, Geody. So with the parent function bit, there's not much you can do besides memorization, but we can try and hopefully make it make sense a bit more. Yeah, Obi, you'll be a lot better explaining this than me. Yeah, because they're just Pascal's triangle, or at least related to it. It's not like perfect after a certain point. The God mode. Oh yeah, we can definitely do that too. You know what? The God mode that's such a quick one. Let me just do that one first, because that's just a formula that's good to know. And sorry, Jada, this will just take a second. So the general equation for a circle, if the circle has center, I'm going to call it h and k. Oops. And the radius is r. The equation for a circle is x minus h squared plus y minus k squared equals r squared. So from here, it's just plugging in the numbers that were given. So it's x minus 2 squared plus y plus 1 squared, and then 3 squared is 9. The part under the x and above the x-axis. Oh, okay. So where the function is positive and negative. -3 to 3 integers. Test values for parent functions. Okay. For the graph part, yeah. Okay, so... Oh yeah, true. For a sphere. Parent functions. This is the speech that I don't have like prepared, so I have to like think about it. No. You don't need to apologize. It's good for me to try to answer this question because, yeah, exactly. Honestly, if you're open to this swing over to Twitch, and Simplex Pachinko has explained this many times and would be able to do it very well. But I'll give it my best shot here. So if you have, I think this will be simplest if we take an actual example. Bosscans, thank you for the follow. Oh yeah, sure. Link away, Obi. It won't be able to, you won't be able to post links in YouTube, but you can just put in the Twitch chat there. And I can send it in YouTube if you want. An absolute value example? Oh yeah, sure. That's a good one. So let's say that our function is the absolute value of x. That can be considered our parent function. Nice. Pass that along. You don't dual stream, do you? Obi is just like your recordings. Okay, so with parent functions, like we consider like this to be our parent function, and the things that we do to it are shifting and stretching and reflecting. Oh, okay. Yeah, so you'll find an explanation from OOE if you search for that as well. So the absolute value of x as a parent function, or just like the absolute value of x looks like that, the God mode, I can do that. You'll be up next after this. Put it down there. Okay, yeah. And so I guess I'll get to that for you, but I'll kind of like build it up piece by piece. So the first thing I'll talk about is horizontal shifts, because I think of it as like we're taking our x and we're just offsetting it by a certain amount. So if I want to take this graph and shift it left by 1, I'm going to take my x and just subtract 1. Now I said a left shift. I meant a right shift. Did I see? This is the part that I always get. This is the one thing with whether it's left shift or a right shift. You know, this is way better done in Desmos. Well, let me go to Desmos. So I was getting mixed up with whether you flip the sign here. That's the one thing with function transformations. Left is positive, right is negative. Okay. Yeah, so this is a right shift. Because this is just a little bit unintuitive to me why -1 is a right shift. But I know why. It's just it never sticks in my head. Everything else about function transformations do. But yeah, so everywhere you see an x, you just subtract 1, and that would be a right shift by 1. And so I think of it as like, I guess it's just in like a horizontal direction x is along the, sorry, our x's represent like all the horizontal values here. And so by subtracting 1, we're just kind of offsetting everything horizontally by 1. Math is not mathing. Yeah. Oh, nice. You had more hair. 2021, that was before I knew you, I think. I want to see how you look. I don't see a difference. I'd have to compare the hairlines, I guess. So number before the absolute value. So if you want to put a number out here, that's going to correspond with a vertical stretch. So if I put a 2 out here, we're going to get stretched vertically by 2. Thinning at the back? Oh, okay, fair. And why? So for the vertical shifts, I really think of it as like I tend to do the transitions or the reflection, or like I think of it as applying it to f of x and then bring it over. So I put a 2 here, but instead I think it's a little bit easier to think about personally if it's a 1/2 times all of our y values. And so we could multiply the 2 over and get the same thing that I just put in Desmos. But I kind of like to think of things that affect us vertically as applying to the f of x piece, and things that apply horizontally as on the x piece. Summit, can you derivatives dividing? I'm not sure what that means. I know how to take a derivative. Not your fan page, or not your type fan page. Yeah, you can ask any math question. I can't do any math question, but you can ask it. Summit, I can queue that up. There's a bit of a line forming. You'll be after... I'm currently on this question up here, and then I have to do the God modes, and then I'll do yours. Oh, no, I can't do that question. I'm sorry. Derivatives of a quotient. Yeah, that's right. And so, that's also why the rules are different for, like, that's why, like, things get flipped. That's why this minus sign trips me up. And that's also why this is a vertical stretch and not a compression. Whereas if I put a 2, I think if I put a 2 here, it would be a compression. It would be a horizontal compression. Maybe not. Hey, Dessen. They're not for another 2 weeks. Um, so in my downtime today, I've been going through the PD section of the complex variables. Oh my god! No one got first? That's wild. Did I study in Harvard? No, I didn't. Yeah, Joseph, definitely first. Hope you're doing well. Tend to use language to modify everyone's initial thoughts about them. I did not go to a big name college. I didn't go to a mathy college at all. There were 3 people who I graduated with in my same major. 3 others. Oh god. Good luck, Dessen. Okay, so yeah, sorry, I'm like struggling a little bit for the explanation here. Two factor on the outside is a vertical stretch factor. Two factor on the inside is a horizontal compression. Right. Okay. That's where the opposite is. So if we take all our x's, the thing inside here, and multiply them by... Why does my monitor do this? 1 second. Okay, there, I'm back. My monitor, I thought I fixed it, but my monitor's been periodically like blacking out, and I don't know why. I physically cannot do that. Not your type. I'm sorry. I wish I could. Do you have points parameterized? Oh yeah, Territar fair. If you can break it into multiple comments, then you can do that. But so that, or put it in my Discord. But okay, so Geode, how I think about it. So forget about the 2 on the outside with the y values. If you can understand, the 2 on the inside is a horizontal compression. We're taking all our x's and multiplying them through by 2. That produces a compression. We could do instead the exact same thing to our y values. Oh, Desmos doesn't like it. But we can instead multiply our y values through by 2, and then just because we always want f of x to be alone, divide the 2 over, so it's now a 1/2. And so the exact same thing we did to the x values, we could also do to the y values. It just gets flipped because of that division. That's how I kind of explain why does that opposite? There's still... Why isn't that work? Oh, because of the... Is it because of the offset? There's something about this that's slightly off. That's confusing me. Yeah, and thank you for asking this question, Geode. I wish I could give you a better explanation, but I'm glad it sounds like I helped a little bit. I would definitely go and look up n-simplex pachinko. The shift happens to the point where the origin is. Ew. Yeah, the God mode, not your fan type. I can only do 1 question at a time, so... I wish I could do everyone's question at once, but I'm only 1 person. No, Geode, you're fine. Good clothes open many doors. Go shopping. Oh my god, Zach, do you just get insulted by a fortune cookie? Yeah, I think we do have a couple questions that are piling up. So for now, I'm gonna move on GOD, but I'd recommend looking up the video that I linked earlier from Ensiplex Pachinko for a better explanation. All right. Oh my god, why is this being... Oh, because of the pen. Okay, so this is the Q as it stands now. So the God mode wants to differentiate y equals ln x squared plus 1. All right, see you, GOD. This is... We need to use the chain rule for this. And so I tend to think of this as working from the outside in. And so I'm saying so a lot. Our outside function is ln. So ln of whatever, pretend it's x for now, or it doesn't matter what, it's just 1 over whatever was inside it, because ln of x prime is 1 over x. And so if we have something that's not x inside, we just do 1 over whatever was inside. So it said now it's 1 over x squared plus 1. But now, chain rule, we have to multiply by the derivative of the inside. So the derivative of the inside, we use the power rule. X squared becomes 2x. The 1 goes to 0. So we got this component from taking the derivative of ln. We got this component from taking the derivative of x squared plus 1. Now just combine it, 2x over x squared plus 1. And I'd say that's the answer there. Let me know if you have any questions. Instead of getting through things quickly, I'm going to go to the next one from Summit. Another derivative, e to the x plus 5x over x to the 1/2. Now you could do a quotient rule here. Yeah, you have to do a quotient rule. Well, you don't have to, but I guess you probably should. So yeah, let's do quotient rule. The way that I remember quotient rule is it's like a mnemonic: low d high minus high d low, and then you just remember over low squared. It just kind of like rolls off the tongue for me, at least. Low d high minus high d low. And what it means is low is denominator, d is derivative, high is numerator. So low is x to the 1/2. Derivative of the high, so derivative of this. Derivative of e to the x is e to the x. Derivative of 5x is just 5. Now minus high e to the x, remember your parentheses, plus 5x. D low, derivative of the denominator. Using the power rule on that, it'll be 1/2 times x to the minus 1/2. All over low squared. So x to the 1/2 squared is just x. So that's how I remember the quotient rule. It's definitely not my favorite rule, though. And so this is technically the answer here. You probably should simplify it. But this is kind of a matter of opinion now, as what counts as simple. The mocks are interchangeable for a product with a negative exponent. Yeah, that's a lot easier to remember. The only thing I don't like about it, or I guess like the downside, is that you have to get the common denominator still, which is a little bit annoying. We could get rid of these negative exponents by multiplying through by x over x. Other than that, I wouldn't really touch anything else here, to be honest. It's just kind of ugly. So yeah, I mean, I would call that my answer. Would I though? I guess I would. I'm not really happy about it, but I guess that's the answer. This one really isn't much worse at all, though. I don't. It might even be better. But yeah, the important part is applying the quotient rule there. So I hope I did a good job explaining that. Okay. Not your type fan page. There are 6 coupons numbered 1 to 6. Let me actually separate this out. Okay, there are 6 coupons numbered 1 to 6, 6 envelopes also numbered 1 to 6. There are the first 2 coupons are placed together. Oh wait, that's an I didn't respond to your other comment. So far it's not bad. We're doing compactification of C and Cauchy-Riemann. Okay. That's at least a gentle enough start, I think. I don't know compactification of C, but you're not making it sound too bad. First 2 coupons are placed together in any one envelope. Third and fourth are placed together in any one envelope. Oh, there's a repeat. Or there's like a copy-paste error. This is kind of funky. It feels like it's a trick question. So let's just go through the process here. The first coupons are numbered 1 and 2. SAT score? I took it twice. I got 1680, then I got 1860. The only reason I remember that is because you just switched the 2 digits of the numbers. When I took it, it was out of 2400. I think it used to be out of 1800, and then after I took it, it went back to being out of 1800. Or 1600, maybe. I don't know. So the first 2 coupons, they have the option to be placed in 3, 4, 5, or 6. So the second two coupons, they can't go in 3 or 4. Now we get cases here. Because if the first two are occupying 5 or 6, that's going to affect the options the second two coupons have. So if we live in the world where there's probably a more elegant way of doing it. I'm not that good with combinatorics, so I just do caveman. The second two coupons, they either have 4 options or they have 3 options. Because the first two coupons might be occupying one of those. What happens with the third? They can't go in 5 or 6. So let's say the first two coupons went in 5. The second two coupons went in 6. That would mean the third two coupons have 4 options. Man, I'm gonna get lost in counting the cases properly. There must be a better way. I was thinking that there's gonna be some type of symmetry here that's going to collapse things, but oh, inclusion exclusion is probably a good thing to think about. I'm just not good with that either. Well, the total number of ways without any conditions is 6 choose 3, right? So we'd want to take that and subtract out the bad cases for inclusion exclusion. Oh, is that just... Oh, maybe that is easier. Is that, 6 choose 3 total ways minus 6 choose 2 ways to do the first 2 envelopes bad minus 6 choose 2 ways to do the second 2 envelopes bad minus 6 choose 2. Is it that easy? Well, I don't know why I said it with that inflection. What number is that? I hope it's not negative. It's negative. Oh wait, I'm doing this wrong, aren't I? Am I? Is it 2 choose 1? I don't know. My combinatoric sucks too bad. This problem, I don't think it should be that hard, but you think it's 16? Total we have 20, I think. That feels low. There should be more than 20. Is there? I don't know. I don't know what to think anymore. Can I make a tree? 1 and 2 can go in 3 and 4, which are like fundamentally the same thing, or into 5 and 6, which are fundamentally the same thing. 3 and 4 have all their options open. Over here, they do not. Treat the envelopes as 3 sets of pairs. 1, 2, 3, 4, and 5, 6. But you don't occupy them as a pair, I don't think. Wait, 3 sets of pairs. Things, I'm not going to know how to count it once I make this tree, but... How many options do 5 and 6 have? So we're occupying 1 of 3 and 4 and 1 of 1 and 2. Yeah, I just don't know how to choose. That's my issue. I tried to do choose, and I got a negative answer. What about that, Jad? Like, this is allowed. Like, you need to use a dummy variable. Like, they might use like t or something. But I'm not sure what you would want to hear about that. They only have 2 options here, so making those 2 lines, I guess. Guess they have 3 options. Six factorial over with really? What does that come out to be? $120. Huh. Oh, that's a different type of question. Okay, so you're that's talking about like fundamental theorem of calculus then, Chad. Um yeah, just make sure I'm not going to say something stupid. Just let me remind myself of how that's going to look. I'm pretty sure I have it worked out in my head. I just want to make sure I'm right. So I haven't done this in a second. Okay, yeah. Um, so I'm just going to quickly do Jad's question, then I'll come back to this choose problem. Jad wants to do the derivative of the integral from 3 to x of 2t dt. And the fundamental theorem of calculus says that when you have this situation, you basically just take what's inside the integral and plug in x instead of your dummy variable. So it's just 2x. Oops. And that's because, kind of like more generally, the integral of a function, the first fundamental theorem of calculus tells you that it's equal to capital, this is bad form. Let me use t's. The first fundamental theorem of calculus will tell you that this comes out to whatever the antiderivative capital F is of x minus capital F of a. But if you take the derivative of that result, the derivative of the antiderivative is just your original function, and f of a is just a constant, so it's 0. So when you have a situation like this, that's why you just you're not actually accomplishing anything. Like derivatives and integrals undo each other. The trick question, or the trick they can throw at you, is if this is x squared, you need to do the chain rule on that x squared. So you'd end up multiplying by a 2x here. Other than that, same deal. Okay, so I hope that helps, Chad. Let me catch up with chat. Ways to arrange objects on all of the 6 factorial bit, then we divide to get rid of the duplicates. But okay, so maybe that's like the total. It's not a derangement problem because the coupon pairs are inseparable. So you have to calculate 6, choose 3, subtract the case for the pair. So yeah, Nihar, that's what I tried to do when I got something bad. That's what I would prefer to do, but I don't know how to do it. Then I would need to be more specific, but I'm going to wrap the stream up after this question. That's a little bit too general of a question for me to answer it anyway. But I don't think I'm going to have time to do it today anyway. Oh yeah, Wednesday. I'm sure with this tree I've made, there's some way to count it with my caveman way here. But I don't know why I made this tree because I don't know what to do with it now. You probably need to go down each branch of the tree. And multiply the number of options? Wait, actually, let's see if this gets an answer that matches. So what I'm going to do, I'm going to multiply down each branch of the tree and then add up each of the results of those multiplications. I don't know if this is going to work. I'm just kind of spitballing here. But that's 2 cubed is 8 plus 12 plus 12 plus only one? Wait. I don't know. 2 plus 8. I don't know. I think that's garbage. 48. Okay. I'm just gonna quit on this one, I think, because I don't know how to do it, evidently. We could Google it. And maybe I can tune into Obi-Stream and learn on Wednesday. This person on Reddit claims it's 64. Oops, I didn't show my screen. Wait, I got the right answer? Wait, or at least Nihar is saying 40. This random answer says 40. $32. No, everyone's saying different answers. Wait, 40. My tree apparently worked. By sheer luck. Yeah. That's why trees are good, kids. Don't cut them down. You can fumble your way to getting the right answer somehow. Four unique objects to put in the envelopes, 3 blank. 4 unique objects to put in the envelopes. 3 blank, 1 each. Oh, I guess you could count blanks, yeah. I guess it's the same thing as just never putting something in the other 3 envelopes. If you don't think about it more, I can like copy paste the text in if that's easier too. So as far as I'm interpreting it, you have these coupon pairs. Yeah, and not the same number. So the coupons have numbers and the envelopes have numbers, and the numbers can never match. The coupons come in pairs, the envelopes are separate. Thanks for working on that problem along with me, Nihar, and everyone. But yeah, I think I want to wrap it up here because I'm getting hungry. I'm sure that there. I think that the better way to do is inclusion exclusion, like Nihar did, but the caveman way works too, I guess. Yeah, I think it's it for me for the day. Which scene is it? So that scene? Okay, I did the right scene. Okay, people here on YouTube, thanks for being here. Nihar, Jad, Ben, whoever. I'll see y'all later on YouTube. On Twitch, we'll look for a raid.